All right, sir. We can go ahead now.
Okay. All right. Well, yes. So basically, the document that I sent you, can you open it up?
Rabbi,
Is it on the JSP email as well? If it's on the JSP, I can share the screen.
Okay. No, I didn't send to GSPR. Hold on.
Well, if you have it, let me make you the co-host of the meeting so you can share it, sir.
Okay. Hold on. I sent it from a phone, so just give me a second.
Yes, sir.
Rabbi, still don't receive mine, sir.
That's Golden.
Is what?
Oh, Israel, you haven't received yours.
No, not yet, sir.
All right. I'm going to try to email it, send it to your email as well.
Yes,
All
sir.
right. Hold on. Israel, did you get it?
I will check it, sir. Wait a second. No, sir, not yet.
All right. All right. In the meanwhile, I'm gonna share the screen, and then hopefully it will reach shortly.
Yes, sir. Yes, sir. Yes. Go
All
ahead.
right. So everyone can see the screen.
Yes.
All
Yes,
right.
sir.
So we're dealing briefly, well, we're dealing with powers of numbers. We touched on it a little bit when we're doing the distributive law in algebra, and even before that, right? But I wanted to do this because where we had reached in algebra, we would need to ensure that we fully understand the powers of numbers before we can proceed, because some of the questions involve a lot of powers. So even though I touched on this a little bit, I want to go into it some more, right? All right. Can I have a reader? Nicholas, can you read for me? Starting with this page.
Two times two times two.
Oh, you have it.
Yeah, times two can be written as 2. How should I put this? 2 over the 2 sides.
2 to the 5th power. 2 to the 5th power.
2 to the 5th power. Index form, where 5 is called the power. But 5 is called the power or index, and 2 is called the base. The power or index indicates how many times we are to multiply the base. For example, 3 to the 5th power,
To the
4th power means 3 to the 4th power. The index 4 tells us that the base 3 appears 4 times in the product.
All right, stop there. So the base 3, right, appears 4 times in a product, right? So the index 4 tells us that the base 3 appears 4 times in a product. And when you look below here now, continue to read.
Hence, where should I start? Hence?
No, thus above that.
Okay, thus 3 to the 4th power equal 3 times 3 times 3 times 3 equal 81.
So stop a second. So basically, as we had discussed last 2 or 3 semesters, when you have the power, so we said 3, which is the base, to the power of 4, right? That is basically saying that 3 shows up 4 times in the multiplication. Product is the same thing as multiplication, right? Product is the same thing as multiplication. So if we count after 3 here, Israel, how much 3s do we have here be multiplied by itself?
4 times.
4, right? So the power 4 is showing you that the base 3 appears 1, 2, 3, 4 times, right? So that is what the power is showing you, and that is what it represents, right? Everybody understands?
Yes, sir.
All right. Okay. Continue, Brother Nicholas.
Note that 9 to the 1st power equal 9 and 1, 0.
Yes, 1 to the 0 power. Yes.
To the 0 power equal 2 to the 0 power equal 3 to the 0 power equal 3 dots equal 1.
Right. So those 3 dots, what they're basically saying is that from 1 to the largest number, if there's a largest number we can write down, once that number is to the power 0, it is 1. So 1 to the power 0 is 1, 2 to the power 0 is 1, 3 to the power 0 is 1, and 4 to the power 0 is 1, 100 to the power 0 is 1, 1 million to the power 0 is 1. No matter what the number size is, once it's to the power 0, it is always equal to 1.
Yes, sir.
All right.
If it is to the power 1, it will equal itself.
Yes, yes, correct, yes. So when it's to the power 1, it will actually equals its own self, right?
Yeah.
So 10 to the power 1 is 10, and 9 to the power 1 is 9. 1 million to the power 1 is a million.
Yes, sir.
All right, good. All right. So let me read a little bit here. So hence any number raised to the 0 power is equal to 1. Example 1. Simplify each of the following products, leaving your answers in index form. When they say leave it in index form, what they're basically saying, don't multiply it out to actually get a number. They're saying multiply it to show the powers, right? And
Yes.
you see what they mean when they say that. All right, so that's A, and you have AI, which is 2 times 2 times 3 times 2 times 3 times 3 times 2. Double I, 4 times 3 times 5 times 3 times 4 times 5 times 5. And triple I, 7 times 7 times 8 times 9 times 8 times 7, right? And part B, remember part B, calculate the value of each of the following. I, 2 to the 8, double I, 5 to the 4, and triple I, 7 to the 3. And then after that, C, determine the value of each of the following. What I, that's 1 to the power 2, plus 2 to the power 2, plus 3 to the power 2, plus 4 to the power 2, and 2I, 1 to the power 3, plus 3 to the power 3, plus 5 to the power 3. All right, so it says here, D, we won't be able to do all of this in the time that we have. So let's focus on example 1, A to C, and if we finish, we can go to the others. So here is a solution for the first one. This is all right, it's a PDF, so I can highlight. All right, this is what we're dealing with. This question first, right? All right, so here's the answer. So what we have here is 2 times 2 times 3 times 2 times 3 times 3 times 2. The first thing we're going to do is group all like numbers. So we group all the 2's together, right? Because if you notice, it's broken up. You have 2's here, then you have 3 here, then you have 2 here, then you have 3 here again, then you have 2 here. So we're going to group them together and put all the 2's in one, like this, and then put all the 3's in together, like that. When you group them, right? And I've said this before, and I say it again. All numbers, if they don't indicate a power beside the number, it is assumed that the power is 1.
Sure.
Oh, yes?
Repeat, sir. Wasn't hearing you for about 10 seconds.
All right. So we're going to group all the 2's together, right? And we're going to group all the 3's together, right? Because right now they're jumbled up together. You see it? They're jumbled. So in the second line, what they did, they grouped the 2's. So we have 1, how much 2's? 1, 2, 3, 4 2's. So we put the 4 2's here, right? Right in the second line together. And then we have how many 3's? 1, 2, 3. We have 3 3's. So we group the 3 3's together. Sorry, right here. All right, everybody see that?
Yes, sir.
Right. Good. Now, what I was saying to you now, any number, once you see a number by itself, any number, whether a million, whether 1, whether 10, whether 2, once it doesn't have a power beside it, the assumption is that, or the fact based on man's you know, wisdom or whatever. But the assumption is that it has a power of 1. So if you see a number 3, for example, it is having an invisible power of 1 beside it. Even though you don't write the power of 1 beside it, you assume that it has an invisible power of 1 beside it, right? So if you have the number 2, the same thing. You see 2 by itself, we assume that the 2 by itself has
Power 1.
a power 1 beside it, right? That is how we treat it, right? Now the next thing is that whenever you're multiplying numbers with a power of 1, so the base of the number is the same. Remember, the base is the actual number itself.
Yes, sir.
If you're multiplying numbers which are the same, for example, right here we're seeing the 2. We're multiplying 2 by 2 by 2 by 2. 2 times 2 times 2 times 2. All the 2's, they're the same value, right? 2.
Yes, sir.
Yes, and we just said we assume that they all have a power of 1. What we actually do is that we
add together
powers, correct, solid, that are present. Okay. So basically, we're gonna add the 1 here for this 2. All right. Let me go to another. Let me try and go to another screen. Let me. All right. Give me a second. I want to show you something. I want to write something, right? So just give me a second. All right. So basically, all right, we're basically out of time. I wanted to show you something, but our time is going to elapse. What I'm going to ask you to do, right? What I sent out to the group for your homework, just go through the document until next week, right? Because we are out of time. And then we will continue next week, right? So just read through the document, right? And anything you don't understand, just you can.
Did you say yes? Right.
Yes.
I was asking, well, I'm not sure. Did you say earlier that you have sent an assignment?
No, it's all right. It's not really an assignment like that. I'm just saying just read up the document I sent you.
Oh, okay.
All right, just read through it so that next class we can continue going through it. Right? It's not an assignment to be graded or anything. Just for you to familiarize yourself with what it's saying, and then I'll continue teaching about it next week.
All right.
It's about 3 pages, I think. So you just read through it. You don't have to do any questions if you don't want to. If you want to do some, you can practice, but just try to understand it until next week when we continue.
All right, sir.
All right. No, Brother Israel, did you actually get the email?
Yes, sir. Please.
Okay, you got it. Okay, good.
No, not yet.
Oh, you haven't gotten it. All right.
If he doesn't get it, I will share it to him, sir.
Okay, good.
Yes.
All right.
Mm.
All right then. So thank you.
Yes, sir.
Have a blessed day.
Yes, thank you. Same to you.